Hey everyone, happy Sunday. It's been a long time since we've done one of these, and today's is going to be a little bit different, a little bit strange, because I want to do some live coding today, and I want to live code with a live cam showing you an odd device that I'm using for our Game Jam game. Before I do that, thanks to Consistent Demon for the follow, for getting us up to the 40 followers. That's exciting to come back to, so I really appreciate that. So I guess, a little bit of introduction about what we're going to do today. Last weekend was an event called the Global Game Jam. Some of you might have taken part, especially if you're game developers. I run the Edinburgh instance of the Global Game Jam, and I wanted to make a game there, as I normally do, while also running it. And I had this idea because of another game I'm working on called CRT7 that can output notes to MIDI devices like this one down here. And I thought it'll be quite interesting, instead of outputting MIDI notes to a synth device like this to play music, what if I used this device as an input back into the computer instead? So I recruited a couple of people onto my team, Cam, who did modelling, and Joe from Joe Plays Puzzle Games, or Joe Plays Games, I really should know because I've played games with him before, to help with some puzzle design and some kind of, user design stuff. And we came up with a game that we called Rerouted, which you can hopefully see in my Unity scene over here. I was the main, or kind of the programmer, and the programming in it was awful because it's a game jam, so it was hacked together to make it work as well as possible in a short period of time. Now, while I'm actually a software engineer, that kind of upsets me a little bit. So today what I want to do is I want to fix it up a little bit and, not make good code necessarily, but at least make code that's a bit more maintainable. So if we want to add more puzzles, we can do that. So we've got this to-do list in the bottom left of our screen today. I will say up front, we're never going to do all 5 of those today. I hope to at least get 1 and 2 done in a couple of hours today. But first of all, let me show you how this works. So first things first, if I come and turn this on, where's the button? There's the button. You should see this thing light up, load in all its patches, go away Windows Update. Cool. And now we've got this thing up and running. This thing has a lot of different features, and we're going to ignore almost all of the features for this. All we really care about is that this grid of the buttons at the bottom and these up and down buttons here. And if we press this button to change it to all pink, this means this entire grid is now sending out MIDI notes. And if we go to our console and we hit play here, what we should be able to see is, once Unity's done its compiling malarkey, when I hit the notes down here, I think I've covered them off my to-do list. So let me get where are we? Let's get the console up and on screen. You should be able to see here what happens every time I press one of these buttons. We get a series of commands sent. And this is a MIDI command that's being sent. And that's what we're going to use to control the game. MIDI commands tend to be composed of 3 things as far as I'm aware. I'm not an expert on this, but generally there's the type of command. So you can see we're sending note ons and note off commands here, and also 2 numbers. The first number is often like the important one. It's normally the thing that has been interacted with. So in this case, this is actually sending each number is a MIDI note, and the second number in this case is the velocity we hit the pad with, which we're going to ignore for this one. But what that means is we effectively have this grid that will send out a bunch of different numbers depending which button we press. And if we move this thing, you can see this is actually changing the lights as well. This is which bit of the MIDI spectrum we're looking at, because most MIDI commands work on 7 bits because they're quite an old standard, which means we can have any number between 0 and 127. So if we press this button up here, you see that's 127. That's the highest MIDI note we can press. If we go down right to the bottom, this should be 0, which is the lowest MIDI note you can press. And you can see we've also got these control changes, and that's what's telling us that we're changing this window of MIDI notes, and we'll come back to that, how we use that. Now, the short version of what this game is one person plays in a room like this, and they have point and click like controls. They can sort of look around the room, and they're these very basic kind of squarish rooms, and we have doors on 2 sides of the rooms, a screen on 1 side of the room, and this mysterious grid on the other side of the room that hopefully you'll see looks a little bit similar to what we've got down here. When people play this for real, you can't both see the screen and the grid of buttons. It's one person can only see the grid of buttons and doesn't have a screen. One person has the screen and can't see the grid of buttons. So it's like an asymmetric 2-player puzzle game. The person who sees the screen has to tell the person what to do on here. So first things first, if we move up so we get those elevator-like buttons, lights to turn off, and these lights on the main grid to turn off, you can now see what will happen when we press a button on here. It turns on or off the corresponding light in the grid in our scene. And this is the core of how this old controller game works. You can also press multiple at the same time, you can toggle them, etc, etc. And we had this thing that if you run that number down to 0 in the top right, that means you're out of button presses. So if you try and press one more, it resets the whole board. And that's kind of the core of this game. We have a series of these little rooms. One person looks around, tries to figure out what's going on, the people have to communicate. And if you link the lights from one side to another, and you solve the puzzle, the grid explodes, and we get this very loud and dramatic door opening sound. Which Joe was very, very proud of, and to be fair, I secretly really love. Once this is open, what we can then do is click, and we'll walk through like it's a Resident Evil game, and then we move into the next room, and each room has a different colour filter on it, just to give some sort of progression. Again, it's a kind of a game jam trick, right? Is that we didn't have time to do lots of different models and lots of different textures, so instead I've put a big colour filter on that I change each round. And each room, there's a slight twist to the formula to solve the different rooms, and then you move on to the next one. Now, the problem here is that to do this in the game jam setting, we made a separate scene for every room, and then we also made a separate script for every room. And that's really rubbish for when we find bugs that we need to fix. And one bug I found there, for example, which I hadn't noticed during the game jam, is the noise of the door openings playing at the wrong door. So it's coming out of the wrong left and right ear when you turn around, which might explain why people were getting a bit confused and looking at the wrong door that was opening. That's one thing we want to fix. But before we can do all of that, I want to make a universal script, and effectively I just want to have it so we have a single scene, and we load into the scene, and depending on some sort of stored number somewhere, it loads the different scene with its different twists. Now, to do that, I do have, where is it? I have a singleton script somewhere. This is all very badly laid out, obviously, as well. Yeah, a global controller. And all this currently stores, this is just something that will survive through all the scenes and is based on a little singleton. All this stores is the circuit frame, which is which up and down state on here is. Basically, I store what comes in through here, and the time taken, which is just how we keep the time across the scenes. Oh, thank you, Tapes New, for the follow as well. Very kind of you. But this is where I'm going to store all of the extra information that we need. So the first obvious bit of information that we need is a int for which is the current room. Let's call it that. And we'll start that at 0 because that matches some of my other stuff. And if we just do the quick thing here, that one I like. Yeah, perfect. So we'll just encapsulate that. so we can get it easily from our singleton. This won't be a an introduction to coding, by the way, so hopefully you vaguely know some coding. But, you know, if you're following along, watching along, feel free to put questions in the chat. I don't promise to give you the best answer, but I promise I'll give you the solutions I tend to use when I'm making games. All right. The next thing I want to do is, if I'm storing this, we need a new scene that will be the only scene we load. And every time we leave the scene, we'll just reload the scene again after incrementing that number. So, I guess the easiest thing to do is to duplicate one of these scenes that we've already got and use that one. So I'm just going to create a folder to tidy this up in the very typical, slightly hacky way. All of these can go into there. The intro scene, by the way, this is a simple little calibration screen. That just means we can make sure we're being able to detect this. Yeah, thanks for the follow there. I'm not really looking for any promotion stuff. Okay. So, as I say, this is a little bit of a calibration screen. It basically tells the one person to click and then the other person to press some buttons on here, because we don't actually know what state this is in when we first start. So we tell them to press down once and then just keep pressing up, and we keep pressing up until we detect we're in this state. Then we press down 4 times, we detect we're in this state, and then I know exactly where stuff's stored for the next scene which loads in. All right, so let's go grab one of these scenes. Now, I need to figure out which is the best scene to duplicate. Probably one of the slightly earlier scenes, because some of the bits start going a bit odd later on. Well, we're gonna have to grab code from all over the place. So let's just, I guess for now, duplicate. Yeah, let's duplicate this scene, because this had some additional things in that we might want. I think we can just copy paste that. There we go. Rename this, and we'll just call this 01 universal scene. And we'll grab that and we'll put that over here. We also then want to go to our scripts, and we want to duplicate the script from the same room, which one are we in? 4. So we duplicate this. It will shout at us for the minute because it will do that. I'll just call that 01U. So it's got a new name. Stick that in. Yeah, it can stay there. And then we'll just have to go open this and make sure that it's got the same name in here to stop Unity complaining. Alrighty. So, if we now go to our new scene that we've created, this will be called Universal Scene. Cool. We'll find in here, just call this game controller now. Find in here we've got this other controller in here, and I'm just going to do a cheap trick to add the other one on here. Move this up here, because then I can easily just copy the basic stuff we need from here into here to make sure I don't break anything to start off with, because these are all our references to elements around the room that we'll need, and we will absolutely end up breaking a whole bunch of these things soon. But for now, let's just get it in a state where this actually works, and then we can start fixing stuff from here. These are some of our sounds. Hello, Studio 369. How you doing? Welcome to what will be a slightly chilled development stream today. Okay, and then we can just hopefully remove that component. Hopefully if we run this, we haven't broken anything major. Are we still? Yeah, that still seems to be responding. Yeah, that's fine. So that scene still appears to be working. Yeah, perfect. Cool. Okay. So that scene's still broadly working. There's a couple of things we'll need to bring in from some other scenes as well. For doing the television stuff, but that's fine. You can see, you can also see how I hacked together those clicky things on the side. I basically just put them as children off the main camera, and then did a lot of fiddling in order to get the arrows in the right position. I think they're just fonts I've just rotated, aren't they? Yeah, very hacky game jam code. Although you can also see there is if we go to our main camera and we remove, it's not in there, is it? It will be in our post-process volume. If I just delete this, you can see what it normally looks like with our post-process volume. We basically made everything white, so then I can filter it by a different color each one and put on bloom and other things. So you can see these will just be like whitish lights. Again, filthy hacks in order to give stuff some personality in less than 48 hours. Cool. So, I guess the first thing I need to figure out is how to make this a bit universal. We have two different potential rooms that can spawn. A straight room, where you have doors on opposite walls, and a corner room, where you have doors in like this wall and this wall. And we'll need to be able to enable or disable kind of those rooms, and also kind of what wall stuff goes on. That's probably a good place to start. In fact, a really good place to start is I've got all of these post-processing volumes for the different levels. So these are like the different colors for going red, orange, yellow, green, blue, indigo, and violet. So I guess one of the easiest things we could do to start off with is we could have that in our universal controller. We could make them all public, or could let those be assigned. What are they called? Probably something like that. We'll just make an array of those. Call those PP volumes. And then I should be able to get that changing. Okay. Nice. Guessed the name correctly. And then we'll make sure to serialize that field as well, so it appears in our inspector. Okay. And then in our start, so this gets our game manager. That's what deals with the input to this. I won't go into that just for now. But once we get our controller, which is an instance of this thing that stores our current room, what we can do is we can say, we've got the main camera. We might need to get the post-processing volume as well. Get component post-processing. Oh no, because it's actually it's the volume we need to change. It's not on the camera. So we need another thing. Probably up here we can assign, unless I've got it here already somewhere. I don't see any reason why I would have previously. No. So let's serialize another thing. Oh, those, they're post-process. They are the post-process profiles, and we also need a volume. PP profiles, volumes, and then we can just down here say that our post-process volume dot profile equals, and then we've got controller dot current room that we set up a bit earlier, and we'll just -1 from that for now. Oh yeah. Cool. So we set that up. We just set this to 1 for a minute, so the game will think we're loading into our first room. We now go into here, into our game controller. Yeah, we've got an array here. We just lock that. Should now be able to drag all of these into here in Awana, and we should have all of our post-processing randomly. You can see I duplicated them and then missed some of the ones in there. So now hopefully if we run this, it will have the red profile. No, because I didn't set, because I always forget to set the other thing. Yeah, the post-processing volume, which we have here. We'll drag that one in, save that, and let's see if that will now go red for us automatically. Fantastic. Now if I set that to say like 8, that should give us the violet one. I think 7 even. No, maybe it was 8. No, it was 7. Cool. Okay, great. So now we're automatically, when we load in, changing our post-processing volume to be the right color one from that list. That is a good first start. All right. Next thing we need to do is we need to set up which level we're in, whether then it is a straight room or a curved room. So if we go to the other scenes, let's go through them. I should say when you spawn into a scene, by default you're pointing north, as you can see by the little compass, which I just realized is also hidden by the little compass down there. And the directions the player go matters, because the final puzzle is basically retrace your path that you've taken through these square rooms on our little grid. So in our first room we want to just start north with the puzzle on our right and the screen on our left. So let's set that as the default state in our special scene. I think it might be already. Yeah. Cool. So the only thing we're missing is we also need, from here we had this other text on our screen. So let's just duplicate that into our new scene as well. Interesting. Why did you not? Okay, so it pastes correctly if we just paste it there and then we can copy that back in. Fine. And we'll have to figure out when to turn that on and off later as well. Right, next steps then. So this will be our first room. So what we'll really probably need in our universal setup is we'll probably need some form of like some sort of method that just goes through and sets everything up for us, because there's going to be a bunch of if statements and whatnot. So let's just do that, because we'll need to figure out whether we're turning on the straight room, the corner room, all the other slight wibbles we're doing. That's okay, 369. This is very much, I call them Sleepy Sunday streams for a reason. It's just supposed to be a chill stream where I'm not too stressed, I'm just enjoying the stuff and people can drop in and drop out and relax, really. Unless we occasionally play a shooter game, and then I'm not relaxed at all. But you know, today's relaxed, apart from occasionally exploding buttons. Alrighty, so we've got the corridor version here. We also somewhere have a corner version of this room. Now, would I have put that somewhere sensible? Yes. So let's stick that in as well. Let's put that in our normal point on a scene graph. If I now make that one go away, yeah, so you can see we've now got corner doors rather than straight doors here, depending which one we enable and which one we deactivate. So I guess the next thing we want to probably make public is that. Which one of these do we want to activate? We'll also have to do some stuff about figuring out which way they're rotated as well, but I've already figured that out in the other scene, so I'll just go and sort that out later. This can go in our list of game objects up here. So we have corridor versus corner. We'll just call them corridor and corner room. So, yeah, they've appeared here, so we can put corridor in here, corner in here. And what we'll do in our game, not our game manager, our controller, is we can maybe just have a thing in here that basically tells us whether it's supposed to be a corner or a corridor for each room. So we can just put private bool array is corridor, I guess, equals, and then we'll fill that in a second because I'll have to go look that up. And then we can just have a getter, so public bool is corridor, and we'll just do a get. Ooh. Oh no, this is going to have to be a proper method, thinking on it. So we need to pass in... no, we don't need to pass in anything because we know the current room in here. So we don't actually need to pass in anything. So I should just be able to do like is corridor current room -1 again? That's when, and put the semicolon in the correct place. Yeah, I'm just minusing 1 from the current room each time because we have that intro scene which is going to act as 0. Okay, so if we now go to our old scenes, yeah, save that please. So this is a corridor, and I'll tell you what we can do at the same time before I forget. So we'll probably also want a private probably don't need a vector free. We should probably just get away with a float. And then do room rotation equals, because sometimes our corridors are going to be rotated by 90 degrees, or our corners are going to be rotated. And what I want to make sure of is that in the corner room or the corridor room, the same door is always pointed to the correct direction for what's going to open and what's going to be the door we've just come from, because that will make my life a lot easier in a second. And we just do the same thing here, I guess. Public float room rotation. Yep, thank you to IntelliSense for giving me a vaguely sensible answer there. Yeah, that all looks correct. And what that means now is we can look through here and we can say for the first level, it is a corridor, so we'll put true, if I can spell correctly. And the room rotation here is 180, so we've obviously flipped it around 180. Just make sure it knows it's a float. In this one, we've got a corner, and our corner is rotated by 90, so that will be false and 90F. I fully expect these to be wrong at some point, but hey. Level 3 is a corner again, but -90, so false. -90F. And level 4 is a corridor that's not rotated at all, so that's true and 0. Let's just put 0F for consistency. Don't think it really matters. Level 5 is a corner, so false 180. Oh, not there. And then level 6 is corridor minus 90. So true minus 90F. Too many commas. And our final room is a corridor minus 90. So that should be true minus 90F. So that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Perfect. Oh, by the way, excuse my slightly rubbishy typing today. I managed to, a while back, don't know how we're going to be able to see this, cut the tip off one of my fingers. So I'm typing minus an index finger, so my other fingers are getting better, but still a bit stupid at finding some of the keys. So I will be typing worse than usual. Yeah, it was an Ari. I had a little bit of a panic when that happened, but it's healing. It was fun jamming with it though. I would occasionally just clonk on something and would be having an entirely normal conversation, and then I would make a noise, and my team would be like, "Are you alright?" And I'm like, "Nope, I'm just gonna go do a swear over there for a minute." Alrighty, so now we have that information. What we can do is down here, we can use that information to toggle stuff on and off and rotate it how we want it. So we have these up here that we've passed in. So we should just be able to say if controller dot is corridor. And we'll just do this kind of long form, because I have a feeling that if I try and do it cleverly, it's going to backfire. We can then say corridor room dot set active true, corner room dot set active false, and then in corner room. And then we also want to then do corridor room dot transform dot local rotation, or local Euler angles actually, yeah. It was new vector 3. It'll be 0. Controller dot current or rotation, room rotation, and 0. So that will rotate it however many degrees around the y-axis that we have set over here. And if we go back to our actual scene that we're working on, our universal scene, we click on this, you'll see that if I rotate this by say 45, that's sort of the degrees we want to be rotating around. We want to be rotating around the y-axis because that's our green arrow that's pointing straight up in this scene. All right, cool. So make sure I've assigned stuff in that. Let's save that. Let's save that. Let's just save everything just in case and see if that even slightly works. So on scene 1, we want a camera. Oh, I left it at scene 7, didn't I? So let's try that again. At scene 1, we want it to go red. We want it to be a corridor, and we want the corridor to be rotated 180. Okay, cool. So we've definitely got a corridor room. We'll sort that out later, don't worry about that. I have noticed I have somehow managed to break the timer. Again, we were always going to break stuff on the way to hopefully getting this working. Cool. Okay, and then room 2 was a corner, so let's do that. And that should have been a corner rotated 90. This should be an orange room. Let's see if that's working. It isn't. Interesting. Because I've not written the else code. That'll be why. So if it's not a corridor, we need to do basically the opposite of this. So that one needs to be false. That one needs to be true. We want to rotate the corner room instead of the corridor room. Let's see if that's any better. There we go. So that is now that is now a corner room. It's just we need to reposition all of the other wall furniture so it's not overlapping and whatnot. Again, that is something we can relatively easily do. But is that rotated minus 90 as well? Or 90? Was it supposed to be 90 or was it supposed to be minus 90? It's supposed to be 90, cool. All right, so that then probably leads us to the next thing we need to do, which is I have this wrapper for light elements, which is empty for now. But if let's say we go back and we set this to room 1 again, it's empty, but it's where I put all of the elements that represent this. So all of this stuff. So if we pause, you can see that now this light elements thing actually has a load of children elements, which is all this stuff. On incidentally, my favorite game jam hack that we did for this is you see you've got all these lovely like lights that one of our team members made. Well, we also wanted these panels so we could represent where there kind of weren't lights, and we wanted one to put our display on. And so my favorite thing is I just rotated it and then sunk it into the wall. So all you're doing when you're seeing one of those panels is you're just seeing the back of one of the lighting elements, which is such a typical like game hack of, we don't want to model another thing, so let's just use the same thing and just be like, boop, everybody's fine, no one can see it. Alrighty, so the next thing we need is basically in each level, this wrapper will be rotated and positioned to a different wall. So for each level, if we store that, we can then move this to the correct wall as well, where we'd expect it, and we will need to do similar for our TV wrapper, which again is positioned and rotated, and it stores kind of all of the elements that will appear on the TV. So we just have 2 wrappers that we want to wrapper parent objects that we want to move around. So again, we'll just probably transfer all that information to here, honestly. Except this time for positions, we'll want to store the whole vector, because I don't think we ever move the Z vector, but we might as well store the whole vector in this case. So we want private vector free array of, what should we call it? Light elements rotation. We also want a private, that's not rotation, that's actually position, first off. And then I guess we probably will need a rotation one, but I think again, the rotation we can get away with just having a single float. So we'll just have a single float for that. And we'll call that one. And then we'll also want for the TV a similar idea. We'll want a TV position and a TV rotation, I guess. Let's just copy and steal some stuff. I've just noticed that one's named wrong anyway. Rotation. Just call this TV rotation. Then we just need to go and grab all of that and store all of that. But while we're here, let's just do some copy pasting. I knew this singleton would come in handy. Then we might as well call this like light element position, and that's going to be this array, and then light element rotation, that's going to be this array. That needs to return a vector free, so it's happy. That just needs to return a float, and then we wanted to grab both of those and do the same for TV position and TV rotation. They're both vector free, so that's fine. That returns that one. That returns that one. So now we just have to go and populate these. That one needs to be a float as well, because again, we're only going to be rotating around the y-axis, so we don't need to copy so many numbers about, basically. And again, we can go into our old scenes and just do this. Can we do this trick? Yeah, let's do this trick. Save myself some time. Okay. So let's start with this one. I guess we'll have to do new vector free in here, I think. It's 4.620. That'll have to be Fs. Happy with that? Cool, we're happy with that. And the rotation is 90F. And then the TV position, I think, can you do the thing where you copy this now? Yeah. Nice. I only learned about that trick recently. It made me very happy. You don't need all the additional extra weird float problems though. And the rotation is 0. Cool. Okay then. So on to level 2. This time we've got light elements are on this wall instead, so we can copy this one. Paste that in. Tidy up the floating point. The floating point arithmetic issues. This is now 0F here. And our TV wrapper, we can copy that as well. Put a new paste. Tidy up the floating point issues, because we don't care about rounding errors. Nobody's actually going to notice anyway. And that's also not rotated because it ends up on the same wall, which saves us a bit of time. Alrighty, where are we? Light elements. So that is the same as, that's the same as our first one. So we'll copy that across, and it's the same rotation. Lovely. I'm just going to delete that out because I know myself that's going to confuse me. And this one is then, we've then got the TV on a different place. So rotation's minus 90. Just do that. Oh no, I didn't copy, so let's copy the whole thing. Am I just copying a single element maybe, rather than the whole? Yeah, there we go. It's very sensitive to where you click when it's quite a packed little interface like you have in all of the Unity stuff. Okay, so that's the first 3 levels. We want this one, number 4, once it's done compiling. That is the same again. So we can copy that. And that. And the TV wrapper is the same as the first level. So we'll put that in, and we can put another 0 in into there. Cool. 3 more levels to copy across, and no doubt we'll have to be back here to do the wire elements in a second as well. But that we'll get to the wires when we get to the wires. So that, do we have this one already somewhere? Why is this one? Oh, yeah. Yes, I remember why. Because this one we rotate upside down as one of the twists, which means I then had to adjust the Y up as well to make it like appear in the right place without stuff clipping. That does, however, mean I have made a mistake here, and we do need a vector free here as well. Which means I will now need to go in and fix all of these. Because these all now need to be vector frees, and they need to be 0, 90, 0. This we can cheat and say vector free dot 0. This one, and that just returns a vector that's 0, 0, 0. This one will be the same. This one will be the same. This one, however, will be vector, new vector free 0, 0, 180, because we're actually rotating around the z-axis, which means on the wall itself, we're rotating it to appear upside down. I'd forgotten we'd done that. Which also probably means I'm wrong for the TV rotations, because we also rotate the TV upside down. So let's fix those quickly as well. First two, we don't need to do anything, so we can just use that one. This one we need to do new vector free 0, minus 90, 0. This one is that one again, just our kind of 0 vector. And this one is new vector free 180, 180, 0, which is probably me trying to hack it to actually appear on the correct wall, because multiple rotations can get a bit weird and overlapped. Because I'm not using quaternions like I should be, because I'm a bad person. 1, 2, 3, 4, 5. Cool. So let's do number 6. We want the light elements, and that's the same as our last one because stuff's still upside down. Yeah, so stuff is still upside down, and come back. But we're on the same kind of wall and layout by the look of it. Is just the TV the same as well? No, the TV is on a different wall, so we need to copy that one. Fix our weird floating point errors. It's always fun when people first encounter floating point errors, and you have to have a bit of a chat about that with them, and they're like, it says my value is 2.5, but actually the code is saying it's 2.49999999995, and you're like, oh no, you've discovered the nightmare of every programmer, which is that binary can't actually store most numbers technically to the resolution we expect, so we get these weird things going on all the time. Okay, this should now be, I think, for the last one. I think we unrotated it for the last one because it felt too mean to have it rotated. So that's that. This is now vector 0 again. And then for our TV, oh yeah, well yes, we need to put in the second hidden TV as well. We'll come back to that later. That's for when you finish the game. It has a hidden TV behind the main door as a quick sort of hack to have an end point to the game. I don't think we're going to be fixing that hack today, so that's fine. Then a new vector 0, minus 90, 0. Okay, cool. So we've set all of those. So we can go back to having these at sizes that are easy to deal with. And if we go back to our new universal scene, that's fine, that's still running. We just need to put in the stuff in here. It doesn't have to be in our if statements because we always rotate them. So do we have the wrappers? I must have given the wrappers, yeah, because I need to actually instantiate stuff in them. I don't have the TV wrapper. So let's put TV wrapper in here. Then we can say light wrapper dot transform dot local position equals controller dot light element position, and we can do all of that again with a rotation. Local Euler angles, light element rotation. Cool. And then our TV wrapper, similarly, we can basically grab all of this stuff and that might work. It's one of those things. I'm actually more suspicious when it does work first time, to be fair. TV rotation. Cool. And this works because we're basically abusing these getters and actually putting lookups in them, which people have opinions on. Alrighty, let's see if that's worked. Oh, I can't even remember what room I set it to anymore. Okay. Ah yes, TV wrapper's not been assigned, because I always do that and then forget. Put that in there. Save the scene. Rerun that. Okay, no errors. That is appearing in the right place. Oh yeah, that's fine. It's appearing in the right place. And that's still working. That's entirely the wrong doors opening, but baby steps. Okay, and now we go into here, and let's say number 2, which was a corner room. Let's see if we've now at least moved the stuff onto the correct walls and rotate them onto the correct walls for this new corner room. Yeah, because you're supposed to have come into south and you're supposed to go out east on this one. So yeah, that's rotated onto the right wall, that's rotated onto the right wall, which is great. So yeah, it just looks like we need to move our wires around. Because you're supposed to have this little wire come in on one side and this longer wire come out and point towards the door at the other side, just so it's kind of clear that there's this connection for where it's going from the panel to the door. So we fixed that. That's looking pretty good. Let's pick a random number. Let's do level 6, because that's one of the rotated ones. Make sure that's working okay. Yeah, that's appearing upside down. Oh man, even when you can see the board, it's still even when you can see the board and the screen, this is still really confusing. Okay, that's fine. The television's turning upside down as well and appearing on the correct wall. Awesome. I think we're good to go. We might find some bugs in that later, but we might find some bugs in that later. Alright, so the final bit then is we probably need to sort out these wire elements. You can see, yeah, you can see here they're all in one wrapper. So this is sort of, this is it coming into one side of the board. This is it coming out the other side of the board down here, going to the door. So we could just have for each level, probably to rotate and position this again, I imagine. We will also come back to the fact I need to actually... I need to move these up and down as well for the inputs and outputs. That's the next problem. Okay. So I guess, because I think I flipped them as well, I think we just need to do this again, basically. Only this time it'll be wire, position, and wire, rotation. We'll hoof all of these out again, just so I don't get confused. And yeah, we just want to return them again, I guess. Yeah. When you start designing, especially puzzle games, you realise that quite a lot of puzzle game design is just storing a lot of values, because you're either storing the initial setup of the puzzle and what the state of every tile should be, or you're storing kind of the solved state of the puzzle, so you can detect the solved state. It's a lot of storage of stuff. Okay, cool. And then if we go back into here, we should just do I have the wire? Nope. So we'll stick that in there as well. And I didn't save that, so it's not going to appear. So let's save that, let it recompile. And then in the game controller, before I forget, we'll drag that over. And now we want down here to basically do this. but for the wires. Wire wrapper, wire wrapper, wire position, wire rotation. Then we have to go set them again. So save everything, back to our old scenes. Okay, so this is, copy this one, and then it's 090. That's easy enough. New, new 090, comma, and again, just tidy this up. Ooh, interesting. Interesting, because the wires should appear on the same walls as the lights. So I wonder if it's the same. Because that would save us a lot of... copying and pasting. So let's just save that now. So that's the same. Let's go to level 2. So that's 0 to 4.600 minus 180. No, so it's not the same. Because I need to rotate it. Summon. Fine. It's not the same. It's not going to take us very long. This is where we duplicate some information. Some people get mad. And I ignore them. Yeah, because I flipped that one 180 round. For whatever reason. Probably to, I say for whatever reason, to make it line up, I assume. Yeah, I don't know why it's a minus 180. It shouldn't matter, because it's a 180 or minus 180 are the same, but just in case. Okay, and this is the same as number 1. So we'll copy you. Copy you. And for 4, I did click the right thing. For 4, it's the same again. Let's not copy too much or get double commas. Okay, for 5, this will probably be a bit more confused. So that's the same as that one. And I don't do any rotations to it. Interesting. Okay. So that can be a vector 3.0. For 6. One, 2, 3, 4, 5. Yeah, cool. That's the same as 5 then. So that can just be copied. That can be copied. And for the final level, we have the same again. Okay. I feel like this is definitely going to be wrong somewhere, but we'll just get going and see how it works. That's why I'm keeping all these old scenes in case I need to refer to them later on, because I figured this all out under a haze of caffeine and pastries. Okay, well, that's looking like it's going to the door. We need to sort out their vertical height separately. That's the next step. But if we go now to our global controller, let's just try the first room first off, and then we'll try the second room. See how we go. Yeah, okay, so that's coming out of that wall. Going to here, it's coming into this room. And that's the door we want to open. I'm not sure it's the door that is opening, but again, baby steps. And for 2... Yeah, so it's coming in that side. It's going on that side towards the door. All right. That's looking vaguely promising. That is looking vaguely promising. Interesting. Yeah, nice. Okay, cool. Cool. So, the next thing I want to do is I want to make sure these are lined up to the positions they're supposed to be lined up to. Because where the wires kind of touch each side is part of the later puzzles. So, this is where I need to do some maths, which will make me sad. Because I could just, like, pre-calculate these, but also I know which of the positions in my code is supposed to be the correct one. So I'd rather just pre-calculate it or calculate it off the maths, because that allows me to do the randomization easier later. So, first step to do that is I need to put a sub wrapper in these. So basically these bits apply to that side of the cable. These bits apply to this side of the cable. So let's put an empty to door wrapper. Just make sure they're all set to 0. Yes, that's fine. So then I want to move all of these into there. Into their Unity, thank you. And that then means if I move this one, it moves all of those cables in a wanna. And then I want to put another say to lights there. That's 0 again, and I'll put those ones in there. That now means I can separately move this side as opposed to this side. Cool. All right. And hopefully you can see why I wanted this all to be in a single scene now, because I'm having to adjust things all over the shop, and if I had to do that across all 7 scenes, I would go a bit balmy. Okay, there's more wrappers in here. We have 2 door wrapper, 2 lights wrapper. Just put an enter in there so it's not all falling off the screen. Save that, come back to our game controller, to door, to lights. Okay, cool. So, let's go to the controller for the first level. What do we actually set? 'Cause I seem to remember. Yeah. Yeah. So, this thing here is a dirty hack for this. Because basically, this, where's the button? I've covered up the button. This, you can pick which scale of MIDI notes it plays in. You can see these blue lights changing at the top, hopefully. They're the different scales it can play in. Which is annoying, because I just want to be able to tell which button it is. So I actually have to do some mapping between which button it is based on the MIDI note itself. It doesn't just tell me it's X4, Y7. It says, like, this is the exact MIDI note you send out. So I have to do this mapping. And that here is a mapping from the major scale, which goes like, basically goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12 when it loops. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I just picked that one because it's a nice easy scale to map, because it's all the non sharp or flat keys. Let's go back over here. That one, I think, if I remember correctly, is the positions in the Y. I think that should be that's the start and the end positions, if I remember correctly, but I might not remember correctly. It's been a week, so, you know, my brain is not remembered. Now, what is that one? Oh, no, here we go. There's the defined start and end positions, which is what I can use to figure out the heights of the two sides. In particular, if I've written these correctly, the end location should be the output and the start location should be the input. We might have to swap some of those around. You can also see this stuff that I'm also going to have to encode up in our global controller as well. But let's just get the code working so it puts in the right place for level 1. And for level 1, let's just copy these into our universal scene for now. And we'll sort out the other stuff in a minute. Okay, so that means our start location is at x0 and y0. So in other words, here. And 7 will be x of 7 is 0, 1, 2, 3, 4, 5, 6, 7, and then y of 0, 1, 2, 3. So in other words, in the first one, we're going from here to here across the board. And now if I actually start this, that should turn those lights on. Interesting. Oh, because they've rotated. Again, another thing we need to fix, but it should. Oh. Also, we'll come back to this. I don't want to get rid of this entirely, because we'll need those numbers for later. But they're basically, if you press any of those MIDI notes, which relate to spaces on the board, then it resets. That's one of the later puzzles. So I don't want to lose those numbers, but they're going to be annoying for the short term. Okay, so now that should be the right answer, question mark? Interesting. Interesting. Why is that not the right answer? Uh-oh. Well, let's set the max steps to the same as in here as well. Target frame, let's set the target frame to the same as well, and the max steps to 9. See if that works. Otherwise, we'll have to go dig into some code fixes. Okay, perfect. There's obviously a thing. Oh, that's right. I remember. I only check the path when you have 0 spaces left on your counter. So in other words, unless you have to use that, because I know the minimum distances in the puzzles, so I set it so it doesn't do the check every time you press a button. Just as a mini unnecessary optimization. Okay, cool. So this knows where we're going. However, these are already the wrong way around, right? It shouldn't matter for the rest of the code, but really, actually, our end location is this, and our start location is this. In other words, our end location's here, our start location's here, because if we go back into our grid, if we go back into our grid in the game, we want this this wire to come in up here. We want this wire to come in down here. In other words, the power's coming in up here and coming out down here in this first puzzle. As the search algorithm for the path is kind of bi-directional, I do a flood fill. So when we get to, I start in the start location, I just say, right, is this lit? And in the underlying structure it is lit. So I go, right, check if this one's lit, if this one's lit. If this one's lit, it then goes, is this one lit or this one lit? And it basically just keeps flood filling down the path until it's visited every lit space that is kind of contiguous. So in other words, because it only checks north, south, east neighbours, it couldn't jump from this space to this space. But if they're like this, it can. And then What that means is you can actually take any path you kind of like, as long as you make this connection. And I just check every time I do the jump, have I got to the end location? So I start the flood fill from the start location, I check if I get to the end location. So previously it was starting here, flood filling up here. Now it should start up here and flood fill back down to this one. And it's still happy. But now if we set those correctly, we'll be able to use those to sort out our start and our end locations. Now, this one is going to be easier, I think, if I set these to start at the bottom and then just have kind of a set distance. We step up. Now, these will already have been done a bit jankily. Yeah, so we've got a Y of minus 0.35 on these ones. And then on the two lights, we have a Y of 0.01, which means we know there's a distance between them, 0.36, I think. Question mark. So what we're going to do here to make stuff a bit simpler is we're going to zero out all of these, and we're going to zero out all of these. And if we hit play, we're going to see where they line up. Yeah, so they line up exactly between these. Yes, that's right, because I've shrunk these relatively. So these are effectively 0.7 apart. So you can see we're going from 1.05 to 0.35, so they're 0.7 apart. What that means is we can move these down by 0.35, y-axis, yeah, 0.35, which is half a step, minus 0.7, and they should then line up. Maybe. Yeah, perfect. Cool, and then we take that, we put that in there. Then what we do in our setup step is we go to door wrapper.transform.local position equals new vector free, and we only care about the y component of this, so we do 0 minus 1.05f plus question mark for now, and then 0 here. And the plus in this case is now, because we're doing the two door, we want the end position. So we want end location dot y times 0.7 f. I don't think you need to do this, but I'm always suspicious. So I'm just going to cast that. Oh, actually, no, it's yeah, it's a vector int. So I'm going to cast that into a float just to make sure it doesn't mess up our multiplications. And then we're going to change the to lights wrapper. Do that with the start location. And we're going to cross our fingers. Oh, that looks good. That does look right. Okay, cool. And now if I change it to say, this is 1, this is 2, they should automatically adjust. Perfect. This is the sort of stuff I really wanted to do during the jam, but did not have the time or the brain power to fix. So, you know what that means? What that means is we now have to go through in each of these cases and store these start locations, target frames, and max steps in our global thing again. So, what are we actually storing? We are storing vector2 ints in this case. So we have a private vector to int array. Say start locations. Private vector to int. It's not going to autocomplete there. End locations equals this again. And then we want just to do public vector to int start location. Hoik this into here. Start locations. End location. End locations. And we also want to grab this target frame value and this max steps value because they're the other things that will change per level. So private, that's just a normal int array. Target frames. Nope, wrong type of brackets. Private int. What did I call in here? Here. Max steps. And then we want to expose those again. I'll keep these all in a bundle. That's a normal primitive int. That's a normal primitive int. That is target frame. Target frames, and that is max steps. That is just that bit. Max steps. Okay, now I could go through and I could replace all of these and not store them locally, but I'm not going to do that because I feel that's going to break things horrifically. So instead, to make our lives a little easier, I'm basically going to do, I'm just going to set them here. So start lock equals controller dot start location end lock equals control end location target frame equals that, thank you, autocomplete, and then max steps equals that. And that means we're just storing them locally, so all of the other stuff should work okay. Now, what we do need to do is we need to now go and set all of these, which means we need to go to our scripts. Basically open that one. Open that one, that one, that one. 1, 2, 3, 4, 5, 6, 7. And of course it's not even going to slightly open them in a sensible order because, yeah, it opened them in reverse order. Cheers for that. No, in there. Thank you. Just want you over there, and then I want you back over here, and I want the global controller over here. Okay. Cool. So, that. That, except again, that's actually the wrong way round. We'll have to go through and just probably swap these at some point to make sure they're the right way around, but yeah, such is life. Then target frame is 65, max steps is 9. Cool. Away with you. We then have this one. And this one. And 60 and 9 again. Oh, no, add them, don't just overwrite them. 60 and 9. And away with you. I think programming is part of the reason I'm always amazed when people don't know the copy paste shortcuts, because boy do I do a lot of copying and pasting when programming to move stuff around. And that's 64 and 7. This sounds laborious, but what's quite nice is if I do this correctly, even though it's in here, I can actually do something where I randomly generate these a little bit later on, which we are definitely not getting to today. As I expected, feature parity is going to take longer than it feels like it should. But that's fine. 62 and 11. There's something kind of meditative about just copying numbers across sometimes, and it's like the code equivalent of tidying up. Sometimes it's just nice to have a bit of a tidy. Even if we call it give it a fancy term of refactoring in coding. It's just tidying up your code. 65 and 8 again. 65, 8. Yeah, we're running out of space over here. That one goes in there. That one goes in there, and it's 63 and 5. Oh yes, I remember why for that one. That's got an extra twist, with some lights already turned on and broken. And then this is the final one, and this will definitely be the wrong way around. I suspect because it's the same as the OG one. But we'll just keep that, and it's 60 and 7. Okay, so that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, cool. So, if we now hit play, let's see if that all gets set up correctly. It does. Now I know which frame it should be, because it should be 4 down from this one. So 1, 2, 3, 4. Perfect, so that's right. We're able to light up the buttons. And we can take any path we want. It's still solving. Now, the noise is coming from the left, which is interesting, because if we now pause, there should be... Close all of these. Oh yeah, that's all our that's all our effects. One-shot audio. Yeah, so one-shot audio is playing from this door. But it's supposed to be playing from this door. Well, actually, that's not quite the right way around. It's playing from this door, which is the door we're supposed to be opening, but we're opening the wrong door. So that's the next thing we probably need to fix. And one way we can think about fixing that is that this room just needs to be rotated 180 because we've got the wrong door around. And the thing is, we're always going to have... So our code for opening the doors is actually on one of the doors, on this door. You can see we've got our audio source here, the door opening, and we've got like our animator. That's our little animation curve, by the way, that is how the door opens. So you see it goes up and then there's a little boop at the top. So that's a little jiggle at the top to make the animation look a bit nicer. Animation curves, by the way, are amazing if you've not used them, because when you're doing stuff in code, what you can do, the code's in here, you can just do this like IEnumerator, a coroutine, and then you just do evaluate. So down here I'm saying here's the time taken between 0 and 1, I think. Oh no, I'm actually doing it properly and saying this is the time taken based, and then we do it up until the end of however long we've made our animation curve. And you just evaluate it, and it will basically, you give it a value on X, and it gives you the value from Y of your curve, which means you can do these really nice, more complicated curves without having to do very much complicated coding. And also you can fiddle with these, and your animators or whoever can make it open however you like, which is really nice. So you can see here, for example, to match the audio, it doesn't start opening until here. But because I want to play the audio and the animation at the same time, I can start them both off at the same time and build the delay into our animation, which makes life a lot easier, I can tell you, as somebody who didn't used to do that and didn't know about it. Okay. However, if now for our corridor, we were just to do this as 0 instead of -180, yeah, now the correct door's opening. So a simple fix is we can now go into, because we've set this up nicely, we can go into here, and just for our room rotation, we just set that as 0. That should fix our basic problem of the wrong door opening. Perfect. I love it when you spend some time making code that works nicely, and then it's just like a change one number fix. And did you see that little bubble at the top of the door? That's for our animation curve. Okay, cool. So. That's good. Now, the thing I can't remember is where is how I set the. Yeah, I can't remember how I set the klaxon off. I assumed it must be in here, but I don't pass klaxon. Oh no, I pass it there in the door animator script. So I must, yeah, I play the clip here. Do this .transform.local position. Yeah, so that should instantiate where the door is. It's on the door. That's interesting. So is it not doing that? So where's our klaxon then being instantiated? That's a light break one. That's our klaxon one. Oh, that is appearing at the right place now. So, and we have positional audio, so it should be playing in the right headphone there when it's klaxoning. Okay, cool. I think that's broadly fixed. So what that then means is the next thing we need to fix is in our build settings. So we've got all of these scenes we no longer need, because what's going to happen is we're just going to have a universal scene. And then, so this one, it will, at some point it will say, where are we saying? Yeah, scene manager load scene 1, which we've just put this new scene in as scene 1. And then in here, just move that over there, we need to check where it's doing scene manager stuff. Yeah, so here we're passing in basically load this scene. We no longer need to do that. So I can actually remove that bit of code entirely. We can just say load scene 1 again. But what we do here, and we'll need to fix this for other stuff later, but what we do here is we just say now controller.scene .room number, was it? Yeah, current room ++. And then we'll leave it. It will increment the room, reload the same scene, which should basically just reload everything from scratch. And that's still not the nicest way of doing it, but we'll reload everything from scratch, basically restart the scene. Because we've incremented the number, it should now load the next scene in. So let's give this a try. See if this actually works. Let's just, there we go. Okay, that's working. I love our over the top light explosion effect. Resident Evil into the next scene. Amazing, and you can see we're still in the same scene, but now it's loaded. Yeah, it's loaded. Okay, we're into the next scene. We have to basically move this down to the right position. Now, this won't be the right answer, because I think, again, our start and end positions were flipped because I didn't really pay any attention to them before, because I think the right answer to this one is actually this way round. Ah. Here we go. Interesting, but now because it's a corner room, we have to do some extra stuff to call the correct method on the door, basically. Also, that's always setting to north, and it shouldn't be setting to north. We'll have to change the letter in there. Oh man, I changed so many random little things. But this is all solvable stuff. So in our start and end locations, this should actually be 0, 3. Wait, so that's... no, don't change that. That's X. So our end position... Yeah, it should be the... yeah, because it's coming out of the right-hand side as our end location this time. So that should be 7. And that should be 3. That should be 0. Yeah, cool. That should be the right way around. Let's just flip that here. Just make sure that's now rotated them or moved them up and down correctly. Yeah, perfect. Yeah, cool. Yeah, and don't worry about this error. This is a weird Unity error that whenever you use the animation curve, sometimes it goes a bit wrong. I don't know if it's if you don't close them properly and they just go away, it gets upset. Okay, now the thing is, what happens is we are testing. So in our update method, we effectively check to see whether people have clicked. I should really put some comments on this. Check to see if player has clicked left or right arrow. To rotate view. So that's that whole lump. This then kind of smoothly rotates you to that and updates the needle and updates the timer. So let's update rotation, compass, and timer. And it really pleases me, by the way, that the timer is based on, or the compass is based on the actual main camera rotation. And then we have the state, and basically if the state's 0, you can't leave. If the state's greater than 0, i.e. 1, I think we only have 2 states at the moment, we can then check for raycasts, and we raycast into a collision volume that's behind the door, which is how we can tell if they've clicked to exit. I think, yeah, they're all going to be called exit trigger north. Oh, we're going to have to move the exit triggers. Damn, I forgot about that. But anyway, we'll come back to that. But what we need is we need the thing that we have this event. So in our game manager, which is the one we haven't seen, this game manager is what listens to this. So our game manager, basically we used what's called dry wet MIDI. It's a library. This is it setting up the device. So if this has to be the first MIDI device on your computer. A bit hacky, we're not fixing it now. It then registers to get any received events, and then we tell it to start listening to these received events. Then if it gets an event, we basically are only looking for note on, note off, and control changes. What we do is we stick them into a queue, and then we just have a few things to then query the queue and dispose of it, and we've made our own little update event, so we can convert the events that come from here into update events. And I just store the type and the values from arguments 1 and 2, mainly because it's a bit of a faff to get them out of these events, and I just wanted them easier to access. So in our update, we, well, let's fix this first, like check to see if exit clicked if state is not default puzzle state. And this basically says check to see if we have any MIDI events to deal with. So if there is any events in our queue, we will loop through them here. We'll grab the event from our queue. Oh, someone's getting arrested or rescued. So we'll grab the event from the queue, and then if the state's 0, we'll do something with this event. Otherwise, this just effectively disposes of it because we don't care about it. It's just so the queue doesn't constantly get filled up with stuff. Because then what happens is you go to the next scene, and then lights turn on and off randomly, and it's very confusing. And here we say, like, are we at the right up and down position based on these buttons? And is it a note on event? If it is a note on event, which is basically the equivalent of a mouse down event in Unity, then we then do this complicated lookup stuff that, oh boy, did this with not enough caffeine. But it basically finds the correct note and converts it from the MIDI random values here into a positional value. Which then means we can update the lights, turning them on and off, and we play a little click. And if we hit what I called a no-no space, then we reset the lights. That's for one specific puzzle that we'll come on to. And if it's a control change event, that's what these buttons send, and this is what ups and downs our target frame. And also we update some lights, we update the broken lights, etc, etc here. Cool. Now, what that means is when we have these and we do this update light step here, we update the materials to turn the lights on and off, but then we also check the path if our number of lights is the same as our max steps. And the checking path is what does our code to see if we've got a contiguous path. It's basically a as I say, a little recursive flood fill. We check contains path node, and then we call the same method on, what's that, east, north, west, south. And if at any point we hit the end location, we set path found to true, which we always set to false when we first do it. So once we get back here, that means we've recursed through all of the contiguous nodes, and we can just check, cool, have we got in the right space? If we have, then we start sending some stuff. Now, the important thing here is we call main door.open door done, which is our return method, which is when we know how to set the state to 1 later on. So there's two things we need to fix here. First of all, the main door is kind of specified externally, so we need to update that, whether it's the corner door or the corridor door. Yep, that makes sense. And then we also need to change the text depending on which direction it is as well. So, what that means is for main door, we actually want to rename this to, let's say, corridor exit and corner exit. And we're just going to duplicate the code on them both because I don't care enough to fix that right now. And actually we'll then have door animator main door. Is that what it's called? In here, just as a private as well. And then what we can do is in our setup thing in here, if we are a corridor room, we'll set main door equals corridor exit. And I should make that have the underscore to show it's an internal thing. And here we'll have main door dot corner exit equals corner exit. And then, so 4 is the correct one for this one. So we'll drag that into corridor exit. And for corner, it is we haven't got it set up because we need that from a corner room. Yep, save that. So in corner, I've actually got it set up to this one. 5. So what I'm going to do, save myself some bother. I'm going to do this and copy that. Then I'm going to delete it in here, paste it in here. Just make that, we'll make it invisible just for our ease of use. And then in our game controller, then grab door 5 into there. Now, assuming I've done all that okay, we should now be able to load into that room, the corner room. I have not, because I've missed a signing. Yeah, stupid curves. Because I assigned it somewhere else in here, did I? Of course I did, so we could... Yeah, of course I did, so we could enable them and disable them. Perfect. Okay, cool. So now, hopefully... Aha. Aha. Well, that's not right. That's not right for a few reasons. Huh. Well, that's reason 1. We we didn't set it to the right thing. Reason 2, we've clearly messed this up. But yeah, let's fix one problem at a time. Okay, but our sound is definitely not coming out of the right place there. Yeah, why is our sound there? That's not right. It should be over there. Okay. There's obviously something weird going on with where we instantiate the sound. But the door did open correctly, which is nice. As I say, we have this, like, exit trigger, but the exit trigger will be in the wrong place. And I suspect what we might want to do is just... I might just cheat and put exit triggers all around, because it should collide with the walls, I assume. Do the walls have collision volumes? Or maybe I turn them off. Or worst comes to worst, I put them all around and I just turn on the ones I need. But anyway, we'll come back to that. Okay. 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 I keep saying, because the bit that's confused me here is why are these the wrong way around? Oh, it will be because I've rotated the whole thing, isn't it? Yeah. Oh, yeah. Because I'm expecting it to be this way around. Which would then sort those out. Okay. 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 Hacky fix time. When we are doing this, it is if this equals 0, we do this version. It's not 0, in other words, if we flip them around, that needs to be double equals, then we will flip them around. that should fix that problem. The other thing is, we have this issue that I've also rotated some of them into the walls, where they shouldn't be rotated into the walls yet in the game, but whatever. That does now, at least, yeah, cool. That shows up in the right locations. Perfect. What I want to see is, how did the lights look in the old level 1? How did I do the... So I must have had some code in this version to do this nicely. That would have been in the build light arrays thing. Yes, this stuff in here. So we're going to need another wee cheeky thing in the build light arrays, I suspect, because I think... Yeah, you see, this has an extra rotation step. Which is, I assume, where I rotate them into the wall. Yeah, okay. So for this, we want to say if controller.room current room is greater than 0, 1, greater than 2, we do this. Because we want them visible in the first instance, in the first 2 rooms, but not in the later 2 rooms. Let's just try that. Going back to our new scene. Okay, kind of. Kind of. Where are they? Oh, but then we also, it has a different, yeah, okay. Okay. You know what? This is where we just... Oh, nope, not that one. We just potentially replicate a little bit of code in a way that I don't care about. So if it's that, we do that one. Otherwise, in the first 2 scenes, we do this code. Similarly, in this one, we do this code. That's just part of the kind of it's sinking into the wall sort of stuff that's causing the issues, I believe. We do that one. Okay, let's give that a go. Yes, nice. And now, perfect. This is what we should be seeing in the early levels to help people sort it out. But then if we go to the next level up, level 3, they should have vanished. Lovely. Now, I think these are probably the wrong way around, but yeah. I think I have to find all of them the wrong way around in here, but you know, we'll just fix them as we come to them. So that should be start location 7201. Because I imagine if I do it this way around, yeah, there we go. Okay. That also means our rotation for the room itself is wrong. And to check that, if we go to the corner room, oh, do I actually have to? I might. Oh no. That means I need to mirror flip the whole room. How do I mirror? How do we? Yeah, because. So what I actually want for this is 0. But then I want that over there, which means aha. Aha. Upsetting. Okay. I wonder if we can be sneaky. Because these -90s will probably have all similar problems. Okay, let's just set 0. F here. And I guess we'll do private bool room flip equals false, false, true, false, false, false. So 0, 1, 2, 3, 4, 5, 6. Yeah, one more. And we'll return that. I prefer room flip to said name, so we'll grab that. Da, da, da. Room flipped, perfect. Needs to return a boolean. Just unpause here. Save this, and then in our universal controller, in our rapidly increasing in complexity thing, here we need to do corridor room dot transform dot local scale new vector -1 1 1. That should then kind of X flip it for us. We can do the same here. Hopefully those will have fixed all of our little bugs for this room. Yeah, so there we go. Okay, it's the correct door opening this time, that's nice. I don't see any other major issues with the room. Yeah, we'll need to fix this screen at some point, but that's fine. That's all good. Okay. Okay, so we've kind of got feature parity up to level 3, kind of, if we ignore this. And the fact we don't have the exit triggers yet. Grog. Okay. Can we? Maybe we can cheat the exit triggers a little bit. That'd be nice if we could. Because we do kind of know... Unity? What the heck? What the heck, Unity? Well, that's an inconvenient addition. We do kind of know that the exit triggers need to live behind these doors. We do know that. So we can do that. Yeah. All right. Yeah. Let's do that. Let's see if that works. I'm suspect. Do we pass in the exit trigger anywhere? Nope. So passing the exit trigger. Then when we're faffing to get the doors, after that we can do exit trigger dot transform dot local position equals main door dot transform dot position, which should be its world space global one, and then I guess let's just put it there for now, because we can't click it until we're in the right state. So that should be all right. And actually, if we're doing that, we can just do that outside of those if statements. Yeah, I'm doing a face because I don't believe this is going to work. But you know, let's find out. So we want to be able to like properly move between the different levels where they have the different targets now. I didn't put that in the game controller. Let's just save that. During the game jam, Unity had a habit of crashing when I was using the MIDI devices. Okay. Okay, that's working. The expected door is opening. Wait for it. Kudunk. We spent a long time making that line up. Okay, we can click and we can leave. That's cool. Okay then. What has gone? What has gone weird in this room? Oh, the room's been flipped. Why has the room been flipped? Because I didn't actually read the thing I was supposed to. Only want to do that if we've set the room flipped tag. Okay, let's save that. Let's just, we know we can move from room 1 to room 2, so let's update that value. Okay, better. Correct doors moving. The sound is still being spawned in the wrong place somehow. I mean, it's being spawned ignoring... It's being spawned ignoring the rotation. Because I don't want to spawn it as the local position. I want to spawn it as its position in the world. Nah. Okay, but hey, look, that's working. And that means we have definitely moved that exit trigger over here. Now, the only problem is... yeah, that's the only problem. Is we'd also need to potentially rotate it. So that's got a Y rotation of 0. Does that exit trigger have a rotation of 0? Okay, well, let's just see how it goes in the new one. Okay. So this is one where the exit door, I think, is north again. So if we now go to the exit trigger, yeah, you see, so that's now roughly covering where we want to click. That door doesn't have a rotation, but the corner room doesn't have a rotation. If we go back to room 2, does the whole corner have a rotation? It does. And if we make that exit trigger of the same rotation, does that then work? Interesting. Interesting. Let's try that. Again, we're using Euler angles because we're monsters. be 0, question mark, 0. The question marks will come from not main door. Oh yeah, yeah. It's not great, but we can do main door dot transform dot parent dot transform. That's so horrible. I'll explain what that does in a second. And then we just want Euler angles dot y. Oh my goodness, that's awful. So transform everything as a transform component, and that stores all of its children's transforms and all of its parents' transforms. So what we're doing here is we're saying get the door that has the script on, then get its transform, so we can then get its parents' transform, which will be corridor. So actually we may not need that extra transform. Yeah, okay. So we're getting the parents. So we get this transform so we can get this parent, which then means we can get the rotation of this. That's just so we don't have to put extra code in both of these. I am suspect about the quality of that code. Oh, and that was definitely sounding out of my right headphone, which means we might have fixed the audio spawning issue. Yes. Yeah. Yes, that is much better. Okay, but have we then also fixed the exit trigger? Oh yeah, that's looking promising. Okay, let's see if this one works. The extra twist here is we basically remove the end lights and you have to notice the wires, which are already sorted. Yeah, that is playing out the correct ear again. And our collision's working, so that's good. Okay, so we're now in the green room, and the green room is where you're supposed to use this map over here that we're nearly fixed. But I'm pretty sure... if you look at the map, our start and finishes are incorrect again. But I assume if we now just do enough random other ones, maybe, no, just to cover our bases. Yeah, there we go. Amazing. This is very close to actually being feature parity. Apart from the fact they're all, slightly wrong and I need to fix them all. This is very close. So this is room 4. 1, 2, 3, 4. 1, 2, 3, 4. Again, these are just the wrong way around. Okay. This is where we flip everything upside down, and now the wires are out of place. That's fine. That's something we can just put an adjustment in when we know it's flipped. So that is not... that is not unfixable. That is not unfixable at all. Now, before we get to that, I want to fix up the level 4 with the no spaces. Now, I think there's only one level that has no spaces. So what we can do is we can just go and see where they're used, and we can just probably be a bit cheeky and say if controller. Well, let's do this nicely at least. So we can have private. Let's do a list of ints just because it's easier. It has some nicer things we want. If you want to do this really properly, it should be a list int array. Am I allowed to do that? Oh, that's a dirty data structure. No spaces equals this. Okay. That's an empty list. So there's no, that's empty for level 1, 2, 3, not for 4, we'll come back to that. 5, 6, 7. This just allows us in the future, if we want to customize this, to do it a bit nicer. And in this, the one where I've put the question marks, what we want is this. Okay. I am surprised it's letting me get away with this code. And this will return an int list. Get. No. Oh, blah, 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 blah. No spaces. We need to give it a variable name. And then we do the same current room -1 trick we've done everywhere else. Okay, and then we just comment these out for now. I think they're only referenced in one place, which is here. So we just then do controller dot no spaces dot contains. And I think that's us. I think that's all we need to do for that one. So we'll just go to room 3. And we'll just check that the basics here are still working. Yep, okay, so down, down. Cool. Okay, cool. So that's still working, door's still opening. Joe is still happy with his sound effect, I'm sure. Now if we get to the right target frame with that, we should be able to now go. Yeah, see now it won't let us go across there. We have to go up and around. Nice. That is working. Now, one bug I did notice is if I do this, and I press the next button, it should reset. It shouldn't complete. However, it resets and completes. Now this is a bug we found in the game jam for one of the other levels, and I fixed one of the other levels, but apparently didn't fix for all the levels. So let's go fix that quickly while we're here. So it resets the lights if we press anything, so that's fine. Interesting. That's not the problem, I think. I think it's we go here. So we say in here, if the number of lights equals max steps, then we check the path. Else, we reset the lights. Now, the bit that always confused me here is we somehow managed to get it so both of these are calling. I think the way we fixed it was a bit... We just effectively put like one of these in. So if somehow we get here and this is now not equal to the max number of steps. We just returned from that. We never bother checking the path. I'm pretty sure that's how we fixed it in the game jam setting for one of the final levels. Let's see if that works here. Oh. Clearly not. Okay, well, I guess it is time. Guess it's time to do our debugs. We've got surprisingly far into some live coding without having to do any like debug commands, honestly. Like breakpoints, I should say. Okay, so we're checking the path at this state, which is correct, because, yeah, so this is when it should finish. And that will go through, and that will, we put a breakpoint there, continue. We won't have found the path, because we've not finished the path, right? Because we've now used all our things. The bit that's weird is now if I press this, it's somehow succeeding in doing a path check. So it's calling reset lights, which is going to here, which is fine. That's going into update light, which then calls check path again. Ooh, because we've now decremented it. But for some reason, yeah, so okay, so when we reset the lights, we only want to check the path if we've we should only call this if it's an on action. Because when you're turning something off, you can't complete a path. At least how we're currently setting it. Oh wow. That drove us a bit loopy at the end of the game jam. Mainly because we were all exhausted. Really a lot easier to fix when your brain's on and you're actually well caffeinated, clearly. Assuming I have just fixed it, of course. Oh yeah, no, I've moved these, so let's just stop the debugging for the minute. Oh, I am frustrated at myself. That is such a... If I just used the debugger during the game jam, that would have fixed our problem immediately. Now, I say it's fixed, let's make sure it still is. Yeah. Oh, you absolutely silly Billy. Okay, cool. Okay, that's great though. Now, the final thing we need to do to make sure we still have the parity for each of these levels is we need to make sure that the screen's being updated, because we have completely ignored the screen so far. To do that, we need access to this text and the image. Let's call this hint text. And we've got the grid room image. That's the sprite. Where do we have? We have counter prefab. What am I putting into counter prefab? Counter. Oh yeah, that's right. Well, it's not the one we're looking for. How are we updating the timer? That must be in our update somewhere. We've got timer text. Ah, yeah, I remember. This was the bit of the day when I got sick of putting everything in as things when I was copying stuff. So, yeah. So I just put them in as separate ones. So that's fine. Let's just follow that standard. And then we'll hint text here as well. Because it's not that many objects when we first start at this stage, so it shouldn't take long to do the find. I don't normally like doing these because they're a bit susceptible to horrifically breaking, shall we say. Then what we need to do in here is one of our final things, is we need to put a private string array for hint text. Because we'll need to update that with our hint texts. And then we'll do a private string I've been doing too much Java. I was thinking it should be a capital. Hint text get that, all of that, -1, all of that. Lovely. And then we do in our setup room thing at the bottom, we do hint text dot text equals controller.hint text. Public. Okay. Then we just have to go through and get all the hint texts, and we can just grab them from the other scenes, save that. Now, they're going to look really odd because font I'm using, certain capitals look really nice, certain capitals look horrible, so I encode that into the string manually. We'll just... it's fine, just ignore that for now. So it'll also make it easier to change these texts because we weren't necessarily happy with some of these hint texts. These were like, if you do game jams, you know that you have the kind of the last half an hour or hour if you're lucky of polish where you just go, right, just put something in for all of the rooms so it looks intentional. And this one we're just going to put blank string in, and we will come back to my plans for that in a second. This one, which can be fine. The next one I seem to remember nobody liked, but we'll keep it as that one for now, because again, we're going for feature parity rather than necessarily improvements, although we have done a bunch of improvements along the way, to be fair, which I'm really happy with. Okay, now we do this, but we then say if hint text.text equals empty text, what we're going to do is we're going to do timer text dot game object dot set active false. So in other words, if there's no text, we're just going to hide all the text elements. And we're going to make the grid element, which I must have passed in. He says, which I probably haven't passed in actually, thinking on it, because yeah, we just had it always on here, didn't we? Yeah, okay. We will pass that in as the final thing. Image hint for now. Ooh. And just by default in the start, set image hint dot set active false. And then if our text is empty, we'll set it to true instead. Then I just need to pass that in. I feel really dirty about doing those lookups now. That's annoying me. So we'll just We'll just expose them. Put compass needle up there as well, so we don't have to do any of the finding operations, which I don't really like. And now we don't have to. We only have to do it in one scene. It should be fine. Yeah, you don't need to be there. Okay. Then we just have to fix all the things I've just broken, basically. Yep, that needs a semicolon there. Okay, so we need to pass in the compass needle. We do in a second. We have timer text goes there. Hint text goes there. Image hint we've already set. The compass needle is somewhere in here. I think it's that one we want. So we'll pass that one in there. Let's see if this all works now. Nice, that's appearing. All the other text has gone away. So if we now solve this puzzle using our fancy controller, everything explodes. The correct door opens. Hopefully then when we go through to the next level, our text will appear correctly back on the monitor like we want it to. Or indeed not. What are you doing over there, monitor? That's not where you live. What? How have you... How on... Okay, the text is appearing correctly. What are you doing in that door? So, yeah, that's clearly not right. Okay, so if we go back up here, we've clearly set that wrong. The TV rotation looks correct. TV position's wrong. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, we're missing one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Huh. That's going to be part of the problem. So it must be setting the position for the final level rather than this level. Okay, so if we go into this one here. Yeah, there we go. That's a different location. So that's final level before should go into here. Oh, you didn't copy that at all, right, did you? So that should be that should be that once we tidy up our floating point issues. Okay, let's go see if that's fixed our issues. Hooray! Yeah, there's our monitor. The timer's ticking up. It's the right text on it. Excellent. And now this should also... Is that the correct... Now is this the correct path? Oh, it is. Interesting. So our wires are in the right position as well. That's a bit of a surprise. I swear those were broken before. But okay, cool. We've obviously fixed something. Okay, and then we go west in that room. That will load us into... Build index 6 couldn't be loaded because I was still running the old scene. try that again. I was thinking that's all worked nicely. There we go. Stuff's out of line, like I thought it was supposed to be. Yeah. Okay, so our monitor's working. Wrong door's opening. So that means what we need to do is we need to fix our rotation. I imagine it's probably a 0 rotation again like we had before. Maybe of the whole room, that would be nice. Oh, is it just a 90 rotation? Minus 90 rotation? Yeah, minus 90 rotation. And then we need to flip it. Yeah. Okay. So for this room, it's a minus 90. 1, 2, 3, and we need to flip it. I'm kind of determined to get to feature parity by the end of this stream now. We've got about half an hour more before I give up, I think. But I've actually made more progress on fixing things than I was expecting. Yeah, I fixed where the sound's coming out and everything. The monitor's correct. That's the right door opening now. And we can still click and walk through it. Okay, this has an extra special thing we'll need to sort out, but that's fine. We are making progress. This is a longitudinal room, so let's just check that this is the correct door. That is the correct door. Okay, cool. Okay, cool. So the next thing we need to fix is when it's upside down like this, where the ends are supposed to actually end up. Now, easiest way to do that is to look at this room again, figure out where the ends are supposed to end up. So we're supposed to have one at the bottom, in the top right, and one step up. I don't think it's what we were getting, even slightly. Yeah, so again, they're flipped around. Our start and end locations, and this is 1, 2, 3, 4, 5. So this should be, I think, 7, 2, 0, 0. Oh. Yeah. Okay. And then effectively, when we're upside down, what we need to do, I guess, is deduct a certain amount from their Y's in these wrappers. So we go to 0. Does that look right? No, that's worse. So, how much when I rotated this light element wrapper did I adjust the Y? I think I adjusted it by half. So if I just do like a plus 0.5 to this. Yeah, so that's lining it up. So I need to do a plus 0.7. So I need to add plus 1.2. Does that line it up? Yeah, okay. That's not too bad. In our setup, again, we can add another additional like requirement when we're doing the wire wrapper stuff. Yeah, so in other words, when we flip it around this way, if we do this bit first, we can then also do this stuff, and we can add a vector to it. So if we add just the vector 3.up, then we can times that by how much we want it to actually move it by. And that should then do that adjustment factor for us. So effectively this is a 0, 1, 0, and you can times that by a scalar to get it to be 0, 1.20. So those little vector hacks are really, really useful once you get used to them. That's not quite right. Let's figure out why that's not quite right. What have I done wrong with my maths? It's not about the wire rotation, it's about... Let's just undo all of this. Yeah, no, too far. Redo some of that. Yeah, so what we want is if the... This is the light wrapper is rotated. So if light wrapper dot transform dot Euler angles dot z it's not equal to 0 basically, then we want to do this code to just adjust them up into the right places. That's supposed to be Z, not X. Oh, yes. That is good. Ah, rotated. Lovely. Okay. Fantastic. I think that should work. I'm going to go through to the next room. And for the next room, I actually need to grab... Well, what I'm going to do is I'm going to actually prep for the next room. Because the next room has what I called yes spaces instead of no spaces. Because I was very tired. But effectively, the one room has stuff in it which if you touch it, resets. This other room had lights that were already turned on and they were broken. So you couldn't turn them on or off. So it was sort of the opposite puzzle, where you had to follow the route that was there, kind of provided to you. Now, what I need to do is I know it's the next level. Oh, it's one level before the end, actually. So let's just do this. Then we need to go into the correct old script. I think will be 6. And yeah, I need to grab this array. And put that in there. And then we need to go and find the code where this works and port that across. Basically where this array is used. Okay, so it's used in the building when we build the light array in the first place, which we do once at the beginning, it replaces this bit of code. The question is this bit all the same as here? It looks to be, actually. Which means we should just be able to do like an easy hot swap. Except this now needs to be controller dot yes. Basically, this does this weird lookup thing to change from MIDI values to kind of location, like a cell location, I suppose. I.e. these locations. But now if we save all of that, and let's just jump straight to room 6, we should see some lights already turned on if this is working. Oh, I was about to say that's a big if. And shocker, the start and the end locations are the wrong way around. Because apparently I just coded all of the start and the end locations the wrong way around. But if we fix that... yeah, so now if we get to the right location, you can see this one here I can't turn on and off because it's broken on or off. But I don't have enough... I don't have enough to just draw my way there. Interesting. Why did they not reset? Huh. Well, there's obviously a bug with the reset we need to fix. But, why is there a bug with the reset? That's interesting. So you're supposed to start with 5 spaces, and you can't go 1, 2, 3, 4, 5 and get all the way over here. So you have to go 1, 2, 3, 4, 5, and basically follow this path of lights. Okay, so it's still solving correctly. The correct door's opening. It's just that reset algorithm's wrong for some reason. And we need to do something special for this last room, because this last room puts them in weird positions. But that's fine, because this last room has a slightly different way of solving it, which we'll need to fix in a second. Now, why is the reset not working? When we reset the lights in this one, do we do anything special? Ah! Yes, we do. We have an extra... So I should have checked... Yeah, I should have checked in here. When's this actually used? It's used in 2 places, one of which is in the reset lights. Okay, so let's grab that out and go to reset lights at the bottom. Yeah, so controller dot yes. Yeah, so we're not resetting stuff. That's a catch to make sure we don't try and reset when there's already an on light there, I guess. So that's probably going to fix our little bug there. Perfect. So there you go. Now we're resetting to the correct number of lights. And nothing that's not supposed to stay on is staying on. Okay, cool. So that means we can now go dot 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 dot. Okay. Fine. So there's two things to still fix. The end level. Where the lights go into special places. And we have a unique solving algorithm. And I'm thinking of a really, really cheeky way to do the end level. Oh, that is a really cheeky way of doing the end level. Yeah, okay, so I think what I'm going to do, for the end level, the wires are going to default, or at least these wires, which go into the floor, to show that you're supposed to go from the bottom to the left, are going to be defaulted to the correct location. And I'm just going to not move the start wires if I'm on the final level. Otherwise, I'm going to remove the start wires. Now, for that to work, I need to make sure the start and end is correct. And of course, they are the wrong way. They are the wrong way around. Well, actually, they will be very different in level 7 anyway. Oh, I don't want to save any changes to this level, so let's undo any changes I've done. One is that one. Oh, because I actually ignore the start and the end in this level completely. Okay. So where's the end supposed to be? The end is supposed to be the top left. So we can set that as 0, 0, 3 for the end. Yeah. And then for the start, we can just ignore that generally. But the important thing is, what we want, if we go back to the new scene, is we want to set that into the right position. So if we load the final room, I'm just going to manually finagle it a little bit, figure out where that position is, because we want it basically coming out of here. So if I remember correctly about my wire elements, as I say, they are 0.7 apart. So I want to do that times 6. That then gets that into the kind of the roughly the right position. Yeah, perfect. Then I want to move it down 1. So I need to minus 0.7. Then I need to rotate the whole thing. Not that way. That way. Not that way. Need to rotate the whole thing. Minus 90, but kind of locally. So that's unfortunate. But that's where our rotation is. Okay. Then we're just going to have to figure that out a bit. Let's try and get that back somewhere where we know where it is. Okay, so if we oh god, what am I doing? 0.7, and then we just times that by 5. That's poking out in a decent location, and then we'll add 0.7 and we'll times this by 5. Okay, and then we need to minus 0.35 from that one. I think we just need to add 0.35 to that one, minus 0.35 from that one, minus 0.35 from that one. And we'll call that good enough for now. So I want to grab the position of this one. And then the two lights, we're going to paste the position in there. And we had a minus 90 on the Z. Cool. Then in our setup, in our universal script, what we can do, it's a universal script that is getting a bit of a chunk. We do this one. If controller.room current room is less than 7, do this. Otherwise we just leave it where it is. Now the only thing is, I think I need to also fix the rotation. Set it back to a 0 rotation. So we can do local Euler angles equals vector dot 0. And we don't need the new in that case. Let's see if our little hacks worked. Nice. Now, and the solution at this stage basically is you're supposed to draw in the path you've made in all the other levels, which is this. So you go north, and then east, and then north, then west, then west. So in other words, we have 1, 2, 3, 4, 5, 6. Then we're in the 7th room here. And it forms a nice little question mark, because puzzles, and also because accident. Now the thing is here, we actually had to hard code this solution for a bunch of reasons. So I'm just going to keep this hard coding. But what I want to do is just sanity check that if we go back to, say, level 3, this still works. And we'll end off this stream by basically just doing a playthrough of the entire thing, making sure I haven't broken anything. And then when I have broken something, we'll do a playthrough again to make sure I've not broken anything once I fix the things that I have forgot I'd broken. Lovely. Okay. Okay. While I'm here as well, I also want to fix that text issue. So we can just do another private. We'll just do it this way. Private string. Direction. Text. And as I said, we start here. So the first one is north. Then east. Then north. Then north. Then west. Then west. I think you actually exit west as well. So that's 1, 2, 3, 4, 5, 6, 7. And direction, text, text, and direction, text. And then in here, we previously have just said do north, but instead we now do controller.direction text. Okay, lovely. Now, the only other thing is, as I say, we basically have in this last one, what we did is on the update lights, instead of doing the check, we had a different check path code. so we've coded a checklist in here. And we do this kind of effectively a for each, where we just check everything. Okay, so that's fine. Again, if we want to do this properly, we should have a private list int specific paths equals, and then we are going to have in here 1, 2, 3, 4, 5, 6, and then this one at the end. This will allow us, if we want to do more complicated stuff later, we can kind of mix no spaces and yes spaces and do more complicated puzzles. And I'm just generally trying to make the code nicer this time than we had last time. This is specific path, specific paths. And in here, when we check a path, so normally we do this one, otherwise we do this for each. So I think the if the paths found's all the same. Yeah, so what we do is we have check path node, or we have private check specific path, where we put that can return void. And what we do if we check a specific path is we set this to true, so we just override that other code. I don't know what I'm doing here. This is probably just a code that's kind of come across with us. Yeah, so I don't think we need to care about that. So we're saying for each value in here, if yes spaces dot contains, so if it doesn't contain that, oh yeah, we're reusing this for storing. We're reusing this, yeah, for adding stuff in when we update the lights. So what we want is rather than that, we just want basically a list that we update. So private list int current on lights equals blah blah blah. And then here in update light, we've just got then a bit of extra code at the top, is that right? Yeah, we've added this extra code into this thing here. So in other words, this just allows us to keep track of what lights are on and what lights are off, or actually just what lights are on, which is what we can then do to check this list down here. And this is controller dot specific path. So in other words, if at any point our current list of on lights does not contain this specific light from our path that we're checking, it means our path can't be correct. So we just basically crash out then, set stuff to false. Well, we don't even crash out, we just set stuff to false. We could actually just crash out, but it's such a small list, it doesn't really matter. But yeah, you know what, let's do it properly and just say we return at that point. However, if we then finish this and we return path still true. So it's kind of the opposite operation of what we're doing here, where we set it to false and then we set it to true. Now, what this means is if controller.room number, current room, equals 7, we want to do check specific path, else we do the normal path check. All right. As always, I'll be shocked if this works first time, but we've been doing all right today. So let's see. We'll go to level 6 just to make sure we've not broken level 6. Okay, level 6 is not broken. And look, it's updated the value. It's a bit hard to see here because it's upside down. But we've updated that to say west. The door's opening. We are indeed pointing west. Sorry. We are indeed pointing west. Let's take our step through. Okay, this is looking right. We now just need to get to the right frame and then do. Hey! And look, it's saying that we have to go west again, which is this direction. And it's even the right door. Oh man, this is coming up gangbusters. And the only thing we need then is we had a special monitor hanging outside the room on the final level. So you'll see we have somewhere. Yeah, there we go. This duplicate thing over here, which just had like thanks for playing, and we updated the number on here and we paused it. So we just need to then pass that into here. We call this like end TV. And we also just want to be updating timer text 2. Where is our timer text? Down here. Timer text 2, comma. And then whenever we update timer text, we just also ignore that for now. Whenever we update timer text, we also just want to update timer text 2. This is just so we can format it in a nice string. Okay. Okay, timer text 2 in there. And we only want this to appear on the last level, this whole kind of thing. So, unsurprisingly, we need one more thing in this whole list, which is exit TV. And then when we set up the room, our final thing in this big setups list of stuff is if controller.current room, it's less than 7, exited TV.setActive equals false. All right. And the final thing we need to do is we just need to pause the game when you exit here, but I just want to make sure that the TV vanishes and appears correctly. TV that I definitely didn't put in here, did I? My brain was thinking, have you put it in there? And then it went, yeah, I definitely have. So let's just set that back to the music, because we've actually overrun our hour by a little bit, or 3 hours I should say. But we're nearly fixed, and I'm not leaving until this is done. Okay, we can actually just have a look. Yeah, our NTV is deactivated. of the things I was really proud of is you can click this the second that bit of animation's finished. You don't have to wait for the whole animation tail to go off. I learnt a bit about animation curves while I was playing around in with this over the game jam. Amazing. Come on, door. Show us the telly. Yes. And there's our exit television. So the only thing we now need to do is when we basically quit, we just don't want to quit in this case. We want to go to in the move to exit code in here. You'll see instead of doing the scene manager stuff, I just commented out, we just pause the game, which is a dirty, dirty hack. But it was good enough for the game jam, and it is good enough for now as well. So normally we do this. Oh, otherwise we do this. And that should then pause it so you can see your final time. Okay, and I think with that we might actually have got to feature parity. Should be very exciting. It means we're in for the final test run through, I guess. Well, I mean, that didn't work. Why have we stopped here, game? Interesting. Do. Oops. Usually the rotation's still working. I guess the timescale doesn't work. Timescale thing probably doesn't work in the editor, if I had to guess. There's a few weird things that don't actually work in the editor, but work when you build the thing. Okay, so that's now loading, that's good. Do. Door opens, do we get a telly? We get our thanks for playing telly. Clicky clicky, we walk through. Yeah, okay, so that then pauses. Now, I'm pretty sure we shouldn't be able to do this, because the update shouldn't still be actually... Yeah, the update shouldn't actually still be running, but that's a bug for another time. Ooh, look at our fancy wiring harnesses. Cam spent a lot of time making those nice. Okay. Alright. So what that means, I think it's time for our first full playthrough to see if we've actually got feature parity. Now, that means we have to start with this thing, and there's one tiny thing I actually really wanted to add, which is we have this kind of custom audio source of ambience in here. I just really wanted to add that to the main camera in here as well, because there's literally no ambience at the moment. And I just wanted to just have the ambience in the start as well. There we go. Okay, so it's telling us to click, so let's do a click. Yeah, this is just this button down here. It can either be in pink or yellow. And in yellow it gives you the full grid, in pink it gives you this other sequencer stuff that's really good when it's a synthesizer, but really bad when you're using it as an input. So this entire start thing is a calibration, basically. So we press that until it's yellow. We press down once, which we don't really care about. The only reason we press down once is because if they're all the way at the top, it no longer generates the up arrow buttons, which is really frustrating. So we're going to press up repeatedly, and when we get to this bit, it detects it. Now it's saying press down 4 times. 1, 2, 3, 4. Okay, that will fade out. We'll load into the new scene. We will load into the correct new scene, hopefully. We try that again. I spent a happy hour on a Saturday morning making these things all fade in and out. 1, 2, 3, 4, 5. There we go. 1, 2, 3, 4. It's actually a little state machine running behind all of these. Doesn't matter for now, but it made me happy. Okay, cool. We've loaded into here. We can turn around. It's telling us to remember our journey. So let's try and remember our journey. It's all nice and red. We've got the disappointed father with moustache door. And these lights are on. So we just have to tell the other player, which is us, to draw this path. That's detected. Everything explodes. Lovely, lovely. And incidentally, I know this seems like a really simple puzzle, but actually the big challenge is communicating this and figuring out how this maps to, how this down here maps to the screen up there. Because the thing you've got to remember is neither person can see what the other person's working with, and in our test it does take a bit of communication at the end of the game jam. When we tested it, it takes a bit of communication for people to actually be able to figure this out. And that's part of the fun, right? Is you've got very asymmetric input methods and you're trying to figure out what the other person can see and communicate it. Okay, so this is started correctly, that we've got these elevator buttons, because if we look over here, it will give the hint of elevate first. And it really pleased me that in this font, these, the V and the A are arrows. So, something that no one else is going to care about, but really pleased me. So in other words, I have to keep pressing down until these lights turn on. That's something I'm going to improve, and all of us think we need to improve a little bit. But for now, feature parity. And again, we can draw our path. Now hopefully, I've also fixed that bug. Yeah, cool. So you can't overdraw the path, you have to actually draw the path, and that's now saying E for east, which is this way. Again, sorry about that, but yeah, we go. So we've now gone north and then east. Our timer's still counting up. We'll go through the new door. This is all working. I'm very excited that so far it's not broken. Okay, then again we move this up. And the twist here is the lights that turn on have gone. So you have to figure out that it's the wires that are you need to connect. So again, we can just connect across there. They all blow up in a really overdramatic way that I love so much. And now it's saying go north again. So we're currently pointing east, go north. We go north, east, north. We'll go through this door again. We're in the green room. And we're like, oh, let's draw a path. Oh, why does it keep resetting? Who knows? So you look around and you go, ah, we've now got this kind of maze on the wall. So it looks like we've got to start here, go up, down, and do a wiggle. So we just start here, and again, we'll just over draw it to make sure we fix that bug. Yep. And now, because it's all one central bit of code, because we fixed that bug, we fixed it everywhere, so we can then draw our path. It's telling us to go north again, which is this way. So we've gone north, east, north, north. In other words, we start here, we go north, east, north, north. Now this one, oh no, everything appears to be upside down. Specifically rotated 180, which confuses stuff, because that's the up button now. Here we go. And again, we have to get from this side to this side. So we might start doing this and go, oh, wait, things are back to front. Okay. So instead what we have to do is go from here, up here, and it's telling us to go west, even though it's upside down. We're going north, so that's pointing north, so that's west. So we've got north, east, north, northwest. We're in this one where we have these already on lights. That will be down. Okay, we're still rotated. Yeah, let's just check that it's... Yeah, fine, perfect. Yeah, it's saying to go west again. It's this way. Everything's sounding in our right ears, or in our correct ears, I should say. So we've gone north, east, north, north, west, west. Now we're in the final room, our violet room, where it reminds us to remember our journey. And now we need to set that to the right thing, and then we go, oh, the wire's coming in from the floor now. So we start there, we go north, east, north, north, west. Let's just make sure this one doesn't have the same bug. It doesn't appear to, which is great. So we can go north, east, north, north, west, west. That's the solution for this final one. It tells us to go west again, which is this way. There we go. Thanks for playing. And hopefully now when we walk through the door... Ah! There we go. So that is feature parity. This all works. We've gone through, we've converted everything from a bunch of separated horrible scenes and copied code into a single, well, two scenes, our intro scene and our universal other scene, that now we just keep reloading, and each time it configures correctly, the correct doors open, it turns on the corridor or the corner piece. It's all good. I'm so happy. I am so happy that has worked. I guess the final thing is we just want to do a build in the builds folder. Just make sure that it builds okay. If it builds okay, that's us. We have reached feature parity. The next thing on our list is spinny lights, i.e. like big klaxony lights that happen when the door opens. So basically two spotlights pointing out from each other that will spin round, and it will make it really obvious that, oh look, there's a warning, there's a door happening. Careful. And if we get that working, in the next time I do some of this, I then have some extra bits to work on. The first one being down, up, 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 up. The first one being backtracking, because the original idea was you'd go through this whole thing, but then you'd be able to walk back through the path. 1, 2, 3, 4. The idea being you could then, if you'd forgotten it, you could still solve it. You just have to figure out, oh, I can walk back through the path now. All is good. What I will do for this as well is I'll just whoop this over here so you can see the compass properly. That's a bit more complicated because you have to remember the state of the rooms being solved, etc, etc. But, you know, very doable. Go here, we have this, we're pointing east, and just be like doot 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 doot. And then yeah, the idea would be basically you come back into this first room and you'd open this other door to escape. And maybe this wouldn't be it. I would need to figure that out because stuff changed a little bit. The final bit is I'd quite like to semi-randomize stuff, so I could kind of randomize where the start and the end points are a little bit, and also how many times, you know, you've got to shift this what I call the frame around. But, you know, that's all nice to have stuff. We have done the essential stuff, the must-have and the should-haves, which is great. Yeah, now we're going east by our compass. We'll have just noticed that our compass slightly peeks out at the edge, so I might fix that. But yeah, I'm really happy with how our compass kind of works. It really fits with the whole square room aesthetic. Everything is squares. I do really like the Broken Light version that Cam made of these as well. Other things we were thinking of, we were going to have stuff so these wires only turn on once you've made the connection. That's another easy thing for me to add in. And also stuff like when you get it wrong, would maybe make the whole set of lights flash, and maybe when you run out of kind of the amount of lights you're allowed to turn on, the thing up here would flash to make it clearer as well. But again, these are all sort of nice to have fixes that I can absolutely add, and they'll be much easier to add now. Now I only have to add them in one place, rather than across 7 different scenes that are all glued together with duct tape and hope. I do just want to slightly shrink the length of that pointer. Okay, up. Nope. Nah. There we go. And even when I'm doing both sides of that, the rotation still confuses me. It's a really fun one when we had players get to that room and realise, because that's when the communication gets very... like, did you mean my left or your left? Or, what do you mean by right? My right? Upside down? Am I going up or am I going down? And people were developing their own little sets of languages to figure that out, which were really fun. The best part of these types of communication games is figuring out a communication that's normally unique to you and whoever you're playing with. But yeah, this is where there'd be like the spinny klaxon lights that would turn on at the same time as the noise starts, so it's this kind of like warning, this door is about to open, don't get crushed in it. Joe would be very keen for me to tell you that it was based off of the doors from Lost. The visuals and the noises. He wanted big kind of crushy blast doors. When I think of big crushy blast doors, I think of Starship Troopers, but I do get where he's coming from. And here we go. For our last room, we have our path that we've taken. Our door opens. We get our thanks for playing. We walk through. TV in the void. This still works, which I need to fix. But hey, I'm going to take that as a really good place to end this stream. We've managed to do point 1 and 2. We've got our universal script. We've got our feature parity down here, where my mouse goes behind it. Which, you know, I was not expecting to get to full feature parity at the end of this stream, even though I've gone on a bit longer, just because these things can be really, really faffy to get sorted sometimes. Thanks for watching. If you dropped in or you're watching this later, hopefully this is an interesting look into how Game Jam code is terrible and how we fix it. But yeah, I'm really excited to go and add some extra features on this. We're also thinking of actually making a second executable that has a version of this, but on like a digital version, so we could release this as a simple 2-player puzzle game for you to play with your friends, because currently we can only really do this in an exhibition setting, and there's one of those probably coming up. We have these things called play parties after the Global Game Jam, and this is why I want to get this all sorted out and ready for so other people can play this, because people really, really enjoyed this. They just like playing with weird, interesting buttons, I think. I certainly do. It's part of the reason I buy this kit when I get projects that let me buy this kit, because I just want these big fancy pushy buttons that allow me to do things with sensitivity. And also up here, although you can't quite see because we've the light's gone out, there's also these dials up here, these twisty dials that I can also detect. So there's extra scope of doing things with twisty dials to solve puzzles as well. And there's something really tactile about these types of devices that I love. Anyway, thanks for joining. Thanks for watching later, if indeed you do. Yeah. I might do some more dev streams. I'm hoping to get back into my usual streaming soon as well, of doing weird buildy games on a Sunday as well. But until then, thanks so much for joining, and hopefully see you in a future stream of some sort. Alright, cheers.